Hi everyone, in today's lesson we're going to talk about other trig derivatives besides sine and cos. But first we need to recall those. So to remember sine and cosine derivatives, remember we know s, c, s, negative c, and that when we find the derivative we just go from left to right. So the derivative of sine would be cos, derivative of negative sine would be negative cos, and if I want to find the derivative of the last piece, I just go around and start again. So the derivative of negative cos would in fact be sine. So what we're going to do now is we're going to use these derivatives here, and we're going to prove the derivatives and derive them of the other four remaining trig functions. So let's start with tangent. So we know from the unit circle that tangent of x can be rewritten. So we know that tangent is sine of x over cos of x. So if we want to find this derivative, f prime of x, all we're going to do is use the quotient rule. Why? Because I have a fraction. So here's my high, here's my low. So we're going to do low first, low times d high. So the derivative of sine, if you look here, is cos. So cos again, minus high, which is sine, and d low. The derivative of the cos is negative sine. So we're going to multiply this by a negative sign. Now that multiplication dot needs to be there, otherwise it looks like you're doing sine minus sine. And this is all over low squared. So cos squared of x. So let's simplify this. So the first thing, cos times cos right here, is simply cos squared. And we have sine times sine, negative times a negative. So a negative times a negative is a positive, so we can make that plus. And sine times sine is sine squared. And this is all over cosine squared. Now, unfortunately, to finish this, you need to remember one of those trig identities from pre-calc, that cosine squared plus sine squared is actually equal to 1. So this is 1 over cosine squared of x. So my derivative, f prime of x, is 1 over cos squared. And we should remember that 1 over cos is the same thing as a reciprocal. So 1 over cos means that it's actually secant. So secant squared. It's okay that it's squared. So the derivative of tangent is secant squared. So if you want to write that over here, if f of x is equal to tangent of x, that means f prime of x is equal to secant squared. And we just proved that. So we're going to do the same thing for the other four functions here, other three. So we know that secant, I'll do the next one with you, and then I think I'm going to leave the other two for you guys to try. Secant is 1 over cos. So we could rewrite f of x as 1 over cos. And then we can do another quotient rule, right? We can make this our high and this our low. So we have f prime of x is low d high, so low is cos times d high. The derivative of a constant is actually 0, which makes this nice and easy. So 0 minus high, which is 1. And then my d low, the derivative of cos, we know is negative sine. So times negative sine of x all over low squared. So our derivative actually simplifies nicely because 0 times anything is 0. Negative times a negative is a positive. So this really simplifies to sine of x over cosine squared of x. Now, in order to find this derivative, you actually have to be a little bit tricky with how you, or creative rather, of how you simplify this. Now, we know that sine over cos would be tangent, but I have a sine over cos squared. So what you're going to want to do is break this up. So you can do sine over cos, and then you have another cos on the bottom because it's squared. So you can kind of just put that there, right? Because cos times cos is cos squared. And then since there's nothing here, you'll just put a placeholder of a 1. So really, this piece, sine over cos, is your tangent. And as we did from the problem in the beginning, 1 over cos is equivalent to secant. So I could put 1 over cos to be secant. So my derivative, f prime of x, is tangent times secant. So again, if f of x is your secant of x, your derivative is tangent times secant. Now, it's more commonly referred to as secant x times tan of x. Multiplication is commutative, so it doesn't matter which one you put first. Okay, so enough of all of these proofs. I'd actually love for you guys to try to see if you could prove this one and this one. So I'm going to leave these two for you for homework. So leave this one and this one. You guys try them the exact same way that I did those two. And then check your answers with the back page because I have all of the derivatives here. So you're doing right now cotangent and cosecant. These are the derivatives that you should be getting. So try those, see how you do. And then we'll start by going over those tomorrow in class. But here are all of your trig derivatives. And here are just a review of all of the derivative rules that we've used before. So let's just put this into practice now with a couple of examples. So the first problem says find f prime of x, or the derivative, if f of x equals this. So what you should notice is that this is a product rule. We're multiplying these two things together. So this first equation I can call f of x, or my first, and my cotangent of x I can call my g of x, or my second. So for a product rule, remember the formula is first times the derivative of the second, plus second times the derivative of the first. So f prime is my first, 3e to the x, times the derivative of the second. Well, the derivative of cotangent is in fact negative cosecant squared. So we'll do that here. So first, it's always helpful to put them in parentheses. First times the derivative of the second plus the second cotangent of x, in parentheses, times the derivative of the first. Well, the derivative of e to the x we know is just e to the x, so the derivative of 3e to the x is just 3e to the x. That's it. That's my derivative. Okay, I'd love for you guys to try example number 2. Example number 2, you're going to use the quotient rule. Why the quotient rule? Because we're dividing two things. So do the same thing that I did here, except use this quotient rule and the derivatives above. Okay, example number 3 says evaluate f prime, so evaluate the derivative at pi over 6 if f of x is tangent of x. Well, we first have to find the derivative, so f prime of x. If you look up here, you can see that the derivative of tangent is secant squared. So I'm going to go ahead and write that down here. So tangent f prime of x is secant squared. And I want to evaluate that when x is pi over 6. So everywhere I see an x, I'm going to put a pi over 6. Now we have to remember that anytime something is squared with a trig function, we can rewrite that as secant of pi over 6, this whole thing being squared. That's what that squared means on the inside. It actually means I'm taking all of it and squaring it. So if we want to evaluate this, we have to first remember that pi over 6 is equivalent to 30 degrees. So I'm really asking for secant of 30, that value squared. So I'm just going to do a quick exact value chart. It goes sine, cos, tan. The 30 comes first. So it goes 1, 2, 3, 3, 2, 1. So if we remember, this one would be rad 3 over 2 for cos. So if I'm asking for secant, that just must mean I have to flip this, right? Because cosine is rad 3 over 2. So secant is flipped. So that value in here is 2 over rad 3. And I need to take this entire thing and square it. Now, you don't need a calculator. Why? Because when you square a fraction, you square the top and you square the bottom. So 2 squared gives us 4. And rad 3 squared, anytime I square a radical, the radical goes away. It's 4 over 3. So f prime of pi over 6 is equivalent to 4/3. All right. Now we've been working with evaluating the limit definition of the derivative and the alternate definition of the derivative. I'd like you to try to see if you could try this one as well, see what it's asking, and leave this one for homework as well. So you've got 4 problems to do. I'll have you get started now, and we'll start class by going over those when you come in. All right, have a good night.